6 developers lost 3 hours when a force-pushed rebase on develop caused duplicate commits and a production deployment with duplicate logic. What broke was the golden rule of rebasing. Let's break down Git Rebase versus merge, how it works, and the exact mistake behind that failure. Both Git merge and Git rebase integrate changes from one branch into another. Merge creates a merge commit that ties together divergent histories, preserving the exact timeline. Rebase replays your commits on top of the target branch, creating new commits with new hashes. The result is a clean linear history, but at the cost of rewriting shared history. When you run git merge, Git finds the most recent common ancestor of the two branches, then combines the changes into a brand new commit with two parents. This preserves the exact chronology. You can see that feature work happened in parallel with main. The downside is that on busy repos, the history fills up with merge commits that add structural information, but no code change. Here's a concrete example. We set up a base commit, then create divergent branches. First, we merge main into feature with no FF to force a merge commit. Then we reset and try rebase instead. Notice how merge creates a commit with two parents, while rebase linearizes the history. Rebase does something more radical. It replays your commits one by one on top of a new base commit. The original commits are not moved. Git creates brand new commits with the same changes but different parent hashes and new SHA-1 identifiers. The old commits still exist temporarily, but will be garbage collected. The payoff is a perfectly linear history that looks like a well-written changelog. Here's the same scenario using rebase. After verifying a clean working tree, we run git rebase main. Git replays the feature commits on top of main's tip. The history becomes linear. If the branch was already pushed, you need to force push, but always use force-with-lease to avoid overwriting others' work. The golden rule of rebasing is non-negotiable. Never rebase a branch that another developer has pulled from. Once a commit is shared, its SHA must never change. Rebasing a shared branch rewrites all commits, creating diverging histories that force every collaborator to hard reset. The most common casualty is the develop branch, where a well-intentioned cleanup costs hours of team coordination. Here's the rule in action. The bad example rebases develop, which is shared. Even with force-with-lease, it's still wrong because it rewrites history that others depend on. The good example uses merge, which preserves the shared history. Seeing the difference visually helps. Before, both branches diverge from a common ancestor. After merge, a merge commit ties them together, showing both lanes. After rebase, the feature commits are replayed on top of main, appearing as if they were developed sequentially. The rebase diagram hides the parallel development, which is great for a clean changelog, but bad for understanding the timeline. The onto flag gives you fine-grained control. For example, if you accidentally branched from main instead of release v20, you can use git rebase onto release v20 main feature checkout to transplant only the feature commits onto the correct base. It's a precise surgical operation. Here's the onto command in action. We have a feature branch based on main, but it should be on release v20. The 3-argument form replays only the feature commits onto the new base. After the rebase, the feature commits sit on top of release v20, skipping main entirely. Knowing which strategy to use in each situation is key. For keeping your feature branch up to date, rebase daily. For landing a feature via PR, use squash and rebase or a regular merge depending on team convention. For merging a long-lived shared branch like release back into main, always use merge, never rebase. Interactive rebase is your pre-PR superpower for cleaning up commits. Interactive rebase lets you squash, reorder, and reword commits before pushing. Here we take a messy history with WIP and typo fixes and squash them into a single meaningful commit. The result is a clean, focused commit history that reviewers will appreciate. Both commands can hit conflicts, but the experience is very different. With merge, you get exactly one conflict resolution session. With rebase, conflicts can appear multiple times, once for each commit being replayed. Each resolution is isolated to that commit's changes. If you're not prepared for this, it feels like something is broken. The escape hatch is git rebase abort, which returns your branch to the pre-rebase state. Here's a Rebase conflict in action. Git shows the conflict markers in the file. You edit to resolve, then stage the file with git add, but do not commit. Instead, run git rebase continue. This tells Git to replay the next commit. If you accidentally commit, you'll break the rebase process. This is the same issue we highlighted at the start. Here's exactly why that happened. A developer rebased the shared develop branch onto main and force-pushed. This rewrote all commit SHAs on develop. 6 teammates had the old history locally and had made additional commits. When they tried to push, Git rejected with non-fast-forward errors because their local history no longer matched the remote. Each spent 45 minutes manually recovering, totaling 18 hours lost. A senior developer rebased and force-pushed develop, rewriting all commit SHAs, causing teammates' branches to diverge and emerge to create duplicate logic that shipped to production. The correct recovery is to not merge. Instead, fetch the latest remote state, then hard reset your local branch to match. If you had local commits on top of the old develop, recover them from git reflog and cherrypick. The key fix code is git reset hard origin develop to align with the rebased remote. This prevents duplicate commits and wasted debugging time. The root cause of the incident was rebasing develop, a shared branch. Even with force-with-lease, rebasing a shared branch rewrites history that others depend on. The golden rule is absolute: never rebase a branch that others have pulled. A common mistake is using force out of habit. This blindly overwrites the remote, potentially destroying commits that teammates pushed while you were rebasing. Always use force-with-lease, which checks that the remote ref matches your expectation before pushing. A common mistake during a rebase conflict is to run git commit after staging the resolved file. This creates an extra commit and breaks the rebase process. Instead, always use git rebase continue to let Git replay the remaining commits. If you accidentally rebase a shared branch and force push, your old commits are not immediately lost. Use git reflog on the remote, if you have access, or ask the developer who rebased to recover the old SHA from their local reflog. The orphaned commits remain in the repository for 30 days before garbage collection. When updating your feature branch from a shared branch like main, use git pull rebase instead of git pull to avoid creating a merge commit. This replays your local commits on top of the fetched commits, keeping history linear. Only do this if you are the sole contributor to the feature branch. To enforce the golden rule, configure branch protection rules on shared branches, e.g., main, develop, to deny force pushes. In GitHub GitLab, this is a checkbox in the branch protection settings. This prevents accidental rebase and force push even by maintainers. When things go wrong, start with Git status to see if your branch has diverged. Use git reflog to find lost commits after a bad rebase. Visualize the topology with git log graph. And if a rebase goes bad, git rebase abort returns you to the starting state. Let's run through some common interview questions. What is the difference between git merge and git rebase? Merge creates a merge commit preserving history. Rebase rewrites commits for a linear history. What is the golden rule of rebasing? Never rebase a branch that others have pulled from. How do you recover from a teammate's rebase of a shared branch? Fetch, hard reset to origin branch, then cherry-pick local commits from reflog. And a few frequently asked questions. Does rebase delete my commits? No, but they become orphaned and garbage collected after 30 days, recoverable via reflog. Can I rebase after pushing to a shared branch? No, it rewrites history and breaks teammates' clones. What is force-with-lease? A safer force push that fails if the remote has new commits you haven't seen. To recap, merge preserves the full context of parallel development, while rebase creates a clean linear history by rewriting commits. The golden rule is never rebase a branch others have pulled. Use merge for shared branches and rebase for your private feature branches. Interactive rebase is great for cleaning up before a PR. And when force pushing, always use force-with-lease to avoid overwriting others' work. Ready to go deeper? Up next, Git stash and cherry-pick, then Git workflows, then GitHub pull requests and code review. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.